Hey everyone, welcome back to another episode of Ask GN, the only series where I break my rule of never putting a question mark in the title to put a question mark in the title, because they are literal questions from our audience. If you have questions for consideration for the next episode of this, you can leave them either in the comments section below or on our Patreon Discord. If you go to patreon.com/gamersnexus, we have an Ask GN channel where you can leave questions for this series, and we also do a separate patrons-only Ask GN episode that is, it's typically got about 5 or so questions in it, and that's only available to Patreon backers who help fund the work that we do. So you can consider joining over there, or you can just post your comments in the section below, and we'll try to get to them. Before that, this video is brought to you by Thermaltake's Tough RAM RGB memory, available from 3000 megahertz up to 4400 megahertz in 8 GB by 2 configurations. The Thermaltake Tough RAM uses 10 addressable RGB LEDs for bright illumination and comes in both black and white kits of memory. Learn more at the link in the description below. So this is, I think, episode 113. We've done a lot of these now, spanning years at this point. And we've got a lot of really good questions for this one. The first question, we've got one about liquid metal thermal pads that I would love to talk about because we've done some testing on those in the past. Overclocking video card mods will feature bearded hardware or Joe Stepanzi. He's going to answer that question. And he's supposed to be filming one unless he slacks, as he often does, and sending that in, so he'll be in this video. Bypassing NVIDIA voltage limits, transplanting GPUs between boards, solder mod follow-ups, and a couple of other things. So for the first question, this one is from Benjamin Chung, who posted on YouTube and asked, have you looked into indium sheets, perforated microsprings, or otherwise as an alternative to liquid metal as a TIM? They claim to provide better watt per meter Kelvin figures compared to liquid metal while avoiding having any gallium. So yes, actually, I haven't looked into a whole lot of them, but a couple, actually many years ago, we did some testing under NDA for a company that was supposed to bring some liquid metal thermal pads, they called them, to market. And it was a liquid metal sheet. It was, I mean, it was kind of like a graphite or an icy diamond pad, except liquid metal. And it had good conductivity, but anyway, we did some testing for them. I can't give precise details on exactly what was tested, what the numbers were, but it's been long enough now that I can give you the most important information. So as part of the testing, we evaluated the performance of liquid metals as well, traditional ones like Coolab's, what is it, Liquid Pro? I think that's what it's called. Coolab's Liquid Pro, Conductonaut, a couple others, a product that never launched was in there as well. And the performance between the liquid metals, ignoring the sheet part of the question, was plus or minus 1 degree Celsius on average. They were all about the same, really. And that was for under IHS testing and over IHS testing. And we never were able to really see any difference between them. That might be different today if I tested it with our new thermal testing setup, but in a real world environment, I could not produce a difference that was meaningful. That might change for things like the metal response to the liquid metal. Some of them might pit more than others. We didn't test for that. But anyway, that's the result was plus or minus 1C. As for the liquid metal pads, the ones that we tested performed worse than most thermal pastes. So that doesn't mean every liquid metal pad or every, as you called it, just, you were talking about perforated microsprings, indium sheets. I'm not sure about those specifically, but I mean, I'm going to look into them now that you've suggested it. But speaking to the liquid metal pad, as it was called to us, I don't know what the material actually was. That performance was worse. It was about 10, 11 degrees worse than something like a 4 watt per meter Kelvin thermal paste on average. So it was not impressive. The biggest problem we ran into with that, and I imagine this would apply to the products you're referring to as well, was the thickness of the pad, where we did a few tests where the first results were so bad that I remember stacking them. I stacked like 2 or 3 on top of each other, and the performance started improving, not because, I mean, you should never stack multiple interfaces. It's not a good idea. But the reason it was improving was because just one of them was too thin, and this was some of the feedback we provided for product development. It was too thin to the extent that if they're just, depending on the socket and the mounting hardware and all that, you'd either be really good contact or you might be missing a few of the microscopic imperfections of the surface. It's it's like too much clearance. It's not filling in the surface. So anyway, Yeah, they were not, the ones we tested were not particularly good. I would have used thermal paste instead at that point. But I do want to be very clear that it's possible that there's better stuff out there. We just haven't tested it. So the biggest challenge was definitely into the thickness. If it's too thick, then now you're just you're definitely going to be worse than thermal paste, because the thicker the interface, you know, the more medium there is to transfer through from your most efficient materials, which is the copper IHS and then the copper cold plate. And anything you put in the middle is always going to be worse, but it's better than air. That's why you put it there. But it shouldn't be that thick. So at the same time, though, not being thick enough, like the first set of pads we tested, meant that the performance was really bad. And that's because you ended up with air pockets, because it just wasn't filling the role of Tim to fill all the spots. Anyway, I have not looked into anything since then. It's been years, and I'm not sure, like I said, how they made that product. It was not discussed with us. It wasn't anything they wanted to reveal to us. They just wanted some help testing it. And I don't think it ever made it to market as far as I'm aware, but it's not a company that you all would be familiar with. So anyway, yeah, if there's interest in this topic, we'll look into it more. I do have the IC Diamond and Carbonaut. I bought it. Roman didn't send it to me. I think his business partner probably would have eventually sent it to me, but I didn't want to keep bothering them, so I bought some. We're going to be testing those on our dummy heaters pretty soon. It's just a matter of, I'm trying to get some kinks worked out on it. Anyway, next one. Overclocking video card mods. This one's going to feature bearded hardware. So the question is from Eudis Taveras. Sorry. Questions for extreme overclockers. When trying to go for crazy high OCs on GPUs, do you perform PCB modifications often, like replacing SMDs, caps, or adding additional power stages, or do you just stick to GPUs like Kingpins or Hall of Fame cards? Also, when you do modify the GPUs, what do you often try to fix? Power limits, weird stability issues, more extreme OC limits. Lastly, what's the coolest or craziest mod you've done? This is a perfect question for Joe, Bearded Hardware. He used to do a lot of zombie and e-power mods on his cards, and we were just talking about how he wants to do more of them for whenever the next generation of GPUs comes out, because getting those OC cards like Kingpin and HOF cards, it's not like they're ready at launch, typically anyway. And so he can do the mods and basically create one by hacking it together. It's not as pretty, but it works. So I'm going to throw it to him for this answer.
What's up, Slackers? We're here in Dunedin, Florida at the Slacker headquarters. Steve was nice enough to forward a question over for his Q&A. So, well, I'd like to think that most of the real good extreme overclockers do all the mods themselves and go through, but that's not always the case, because it can be quite difficult, especially when you got these giant hands here. But yeah, usually before NVIDIA started really going through and blocking a lot of stuff, we used to mod cards quite heavily. So I have two cards right in front of me. This is a NVIDIA 980. So this was a Maxwell architecture. So this is a full gigabyte power card. Modded, what it's doing is it's basically taking over voltage completely. So basically the controller is taken off from the card, and this is now in control of basically all the GPU power going to the card. It also has, like, say, a memory mod. You can do memory controllers too, but then you don't really necessarily need it, because it's usually only like a single phase or dual phase. Nothing like going to the GPU where you can have like 8 phase. So, but yeah, this is the 980. The next part is you have the Titan X Pascal. So this is a card that basically has the GPU power, and also the memory power is on there too. So this was a Titan X Pascal. I think this is probably one of the best ones I had. It was a really, really good card on air and water, but on liquid nitrogen, it had what's called a memory issue. So basically what happened is it would cause issues. It would just basically fail at around -60. I should have tested before I did all this crazy modifications to it, but I didn't. And basically I'm stuck with a card just like this. So, but it still runs really well. I mean, the card does over 2K for a Titan X, which is pretty awesome. Memory works real good. It's just you need 2 power supplies to really run it. But yeah, these are the type of things we do. I mean, a lot of the times on the newer cards, I was just talking about on my stream how I wanted to do, probably for the next one, the 3080 Ti or whatever, the newest GPU that comes out, that I'm probably going to end up power carding that on my YouTube channel. So, but yeah, let's finish the question. But I think that pretty much answered most of it. But I want to go in and, let's see. I mean, this will still never end up going as fast as, say, something like a Hoff or a Kingpin. There's just, when you're starting to introduce stuff like this with basically the copper, you're basically creating a lot of noise. So even if you do all this, you're only going to get so far. It's still better to go for the Hoff cards, but I feel like if you want to learn overclocking and go through, I don't really think there's anything better than doing something like this. So that, don't get me wrong, I love the Hoff and the KP cards. They make for the all-around the best. I mean, they're gonna be better than something like this, but you never know. If you find a golden GPU on this one and have a really crappy GPU on a KP, this is gonna do better than the KP. So it still comes down to the best GPU in Silicon Lottery. So let's see what else. I think that's it. What other limits do we usually do? I think I went over, but we basically go over, do OCP mods, volt mods. A lot of the times, because when the die shrinks, they're not using as much power. So a lot of these mods might not be totally necessary, but it really depends on the card and the architecture and stuff like that. So, but yeah, usually, I mean, the technical mods we usually do are volt mods first, and then a lot of the times NVIDIA blocks that stuff, so you got to do an OCP mod. Also, like shunt mods that Steve's shown you with like High Cookie. High Cookie actually created this gigabyte power card. This thing's probably about 5 years old now. It's pretty old. But yeah, this is one of the coolest and craziest. I think this card alone basically was modded probably about 25 times. So when I was trying to figure out and where's the best way to get like ground, for instance, like this section is ground, and then you have power underneath. So, like, I don't know if you can see from there, but my big ass finger's in the way. But yeah, this card was basically modified like 20 times. I had E powers on it, G powers on it. I've had all sorts of stuff. So I guess I'm most proud of that. And then this Titan X Pascal, there's really nobody who's done Titan X Pascal. So, or at least for a couple of years, it took a while before the people did. So, but yeah, so I think that's answers all the questions. So, I'll give you back to Steve, and if you want to check out some cool-ass streaming, liquid nitrogen stuff, and subscribe to my channel and check it out on Bearded Hardware. We're going to be doing lots of stuff even this weekend. We should be doing a couple streams on the 3950X. So, all right, Slacker out.
So that was Joe. Check him out on YouTube. Ever since all the lockdown stuff, one of the few positives is that Joe has had more time to make videos. So you should go check out his channel. We'll link it below. It's Bearded Hardware. He does extreme overclocking streams, stuff like that, and gets really into the overclocking details, so you might have some fun over there. Okay, next question, and thanks to Joe for answering that one. Next question, bypassing NVIDIA voltage limits. This one is from our Patreon Discord, and it's from Dicycle, who says, Steve, is there any way to adjust memory voltage or raise the core voltage limit on RTX cards yet? Yes. So we showed something from Elmore Labs, and if you search the channel for Elmore Labs, E-L-M-O-R, you'll find the video we did, I think. So it was from Computex 2019, if memory serves correctly. And Elmore's got a controller that you can hook into devices, so you can control voltage on supported voltage controllers that he's got entered into his system. And you can bypass some of the limitations. I have one. I need to get around to using it. I tried using it ages ago, and I don't remember which AMD card it was, but at the time it wasn't supported yet, and so we didn't finish the content. But I do very much want to try it out on the Titan RTX. If I remember correctly, that one's supported. I need to check with Elmore, though. But anyway, the answer is yes, there's a way to do it. I'm sure there's multiple ways to do it, but if you check out our video from Computex 2019, just search the channel for maybe GPU voltage control or Elmore Labs, or Elmore's Labs, and you'll find the content talking about it. It's cool stuff. It's an external hardware controller, so there's not much that NVIDIA should be able to do to block it because you hook into it through a third-party piece of hardware. So that's about the best way to get around any limitations. Next one, transplanting a GPU. This one is from Vikram Sri Kumar, who says, out of curiosity, how difficult would it be to harvest a GPU from a graphic card PCB and put it onto another PCB with better components? And would it work? For example, taking a higher bin 2080 Ti from a Founders Edition card and putting it on a Kingpin PCB or something similar on the AMD side? Excellent question. So the answer is yes, you can do it. And the answer to how difficult is it is yes, it is difficult. So how difficult is it? Yes. Yeah, so there's a couple things here. First of all, I regret to inform you that we almost had a video on this precise topic, and it really pains me to see a question about it because it tells me that we were hitting the nail on the head with wanting to do the topic. When we were in Taipei, one of the videos we wanted to do is work with Kingpin, EVGA's overclocker, and his in-house engineer. And then we were going to go over to EVGA's solder shop in-house at their HQ, work with his engineer of choice, and transplant a GPU from one board to another. And so the reason he does this is, I guess you could if you're extremely wealthy or something, but he does it in a lab environment where they have access to everything. He does it because his job is to set world records. And what he'll do is find a board that has extremely good memory on it and a board that has an extremely good GPU on it. And what do? Well, you have your guy in the lab down the hall pull the GPU off of one and put it on the other, or vice versa, I suppose, but I think it's easier to do the GPU swap. So people do this, and it's something we're going to film, but unfortunately due to the human malware stuff, we ended up not being, EVGA was one of the few companies we couldn't access. So yeah, as for watching content anyway, there is a guy that I found. I went and looked into this topic to see if I could find anyone doing this to help point you in the direction of what it looks like. There's a channel I think called Eli Tech or Eli's Tech, and he's got a video. If you search for Eli, and then 780 Ti, you'll find the video. It shows the whole process. So you have to manually ball the GPU. It looks like it takes ages. I haven't done that. It looks painful, and then you have to do a lot of work with a heat gun, moving solder balls around, lining everything up, and being very careful. So he transplanted a 780 Ti, I think, onto a 780 board and got the expected uplift from that mod, and it did work. So, I mean, yeah, I really want to do that content, but we need an expert to work with on it, and unfortunately we were unable to do that because of poor timing. But we'll get it next time we can visit there. So, next one. GPU solder mod follow-up questions. This is from the RipJ video we did. We've had that series. Jade does RipGN videos. We've done RipJ videos for a couple of years now. And it took us a long time to finally respond to them, but we did get to it. And there were some follow-up questions. So the video that they were posted on was the one about soldering a shunt resistor onto another shunt resistor to do a piggyback mod. There are better ways to do mods to lift the power limits, but this is one of the most common ones. It's not necessarily something we recommend, but it's a common one. So first question on this topic is from the political one, who says, does the Kingpin editions of GPUs have those safety precautions? That's a very good question. So this is referring to how shunt resistors on the board are part of the system NVIDIA uses to detect how much power is being drawn and then to figure out how to gate that power. So if you're drawing, let's say the limit set to 250 watts, the shunt resistors are part of the system that detects how much power. If you piggyback more shunt resistors on there, like we did, then you can trick the card into thinking it's drawing less power, and it'll allow more to go through. Even though it's already hitting the limit, it doesn't know that it is. Now there's, again, just to recap, a downside of this where you can't just short it with a wire, which would be the easiest thing to do. And that's because you'll trick it and set it to, well, you won't trick it, it'll do what it's supposed to do. It will think it's drawing way too much power, and then it'll go into 2D clocks mode to protect itself. So that's the safety precaution being referenced here. So Kingpin cards and similar cards, the biggest thing they have going for them is VBIOS and external software that can tune things like voltage, vCore. We talked about this in the earlier question. You don't need a third-party hardware solution you can get something like a Kingpin card and use the classified tool, which is technically not an EVGA solution. It's technically an XDevs solution for reasons relating to NVIDIA. And that can control the voltages, the memory voltage, everything. And the safety precautions exist in the stock card, but once you put the XOC BIOS on it, which is not technically an EVGA BIOS, it's technically an XDevs BIOS. XDevs, by the way, is run by Tin, who used to work at EVGA and made these cards. But you put the XOC BIOS on there, and the power limit is lifted tremendously. Sometimes there is no power limit, depends on the card. And so the answer is no. They don't really have the same safety precautions. They are explicitly removed. Part of the reason that these cards, and we talked about this in our 2080 Ti KP review, part of the reason they're so expensive is because they do all the board work for you and because they remove those safety limitations. So you're paying for the removal of the limitations. Joe obviously knows how to do a lot of this stuff manually, but depending on who you are, that might not be worth it. You might not be able to. You might have more money than you have time, whatever. So that's part of what you're paying for with the Kingpin or HOF Galax cards. And the other thing you're paying for is that the VRM is higher end. So even though we lifted the power limit on the Titan RTX, that VRM, and it is a pretty good VRM, it's getting toasted without extreme cooling. So that's the other part you're paying for. But mostly with these high-end cards, it's just the fact that the board is built up to the point that you don't have to do any mods on it yourself. It's ready to go. So for some people, you know, if you're Buildzoid, if you're Joe, you might kind of enjoy doing all the mods yourself. And Joe, I know he likes working with the Kingpin cards because you can just plug and play. But for a lot of people, plug and play is preferred to doing the mods, either because don't have the knowledge, I don't, or don't have the time, or don't have the money to risk for something you're modding. But yeah, that's the answer for why those are expensive, and no, they don't have safety limitations. If you want to learn more about that stuff, watch our Kingpin 2080 Ti review. Those cards, they're not worth buying in the sense of using it just like stock out of the box. I mean, it's fine. It does well, but it's really not worth spending money for that. They are meant to be overclocked. You don't have to, the liquid cooler is pretty good. You don't have to go liquid nitrogen with it. It's more fun to do that, but you can still push the voltage up to like high 1.2s, maybe 1.3. Don't remember what Tin's recommendation was. Check XDevs for it. But you can push the voltage up even with the liquid cooler, and that's still something you're paying for. It's a feature that's kind of nice to have if you like overclocking. Next one was from Reese O, I think. Says, is this possible to do this on other cards like AMD cards? This is still part of the follow-up questions. Seems like a dumb question, but we all know there is no such thing, only stupid answers. Or is it more similar to the reg edits on the AMD cards? So this is a good question. This specific mod isn't something you would do, to my knowledge, on AMD. There are a lot of hard mods you can do to cards. It's basically endless. I'm not an electrical engineer. I'm not even close to an electrical engineer. Buildzoid would be much closer to that side of the enthusiast world than I would be. But I know enough about it to give you an idea. So we did a video with Tin a year ago. And like I said, Tin used to work for EVGA. He left recently so he can move to the US. But he did a video with us on some really cool zombie mods and basically DIY video card is how he builds the video. And what you can see in there is other types of mods. These are NVIDIA cards that he did, but it's the same idea, where this is other stuff you can do. You add on extra boards with a bigger VRM. You can even buy VRM boards from Gigabyte used to sell them. EVGA, I don't know if they still sell them, but they're the only one I can think of recently that did. And you can buy an extra VRM board and just add it in to your existing card. So that's a type of mod you could do to increase the power capabilities of the voltage regulator if you had lifted power limits. For AMD, the power play tables are the most common way to modify the amount of power going into it. I really hate working with the power play tables. Igor and Helm, I think, and whoever else is involved in making them, they do a really good job. Unfortunately, AMD also does a really good job of trying to lock all of it out. So reg edits work, but they're a huge pain in the ass to do, as someone who's had to do them on stream. And if you can do hard mods, if you're skilled, that'd be the better approach. And I would strongly recommend watching some of Buildzoid's content for some ideas on what you can do there. But no, this specific mod, to answer the question, would not be one you would do for AMD, but there's still plenty of other stuff you can do. Next one, last one from this section before we move on. Blah Pogo says, if the graphics card goes into 2D mode, is there a way to reset it? Does it reset on its own if you put the resistor back? Would placing 2 wires parallel to the shunt resistor onto a breadboard for easy swap shunt resistors help, or does the resistance of the wires themselves become an issue? I loved this part of the question because when I read it, I kind of realized, like, that's a brilliant idea. I hope it works. So the reason I like the idea is because if I understand you correctly, you could run 2 wires off this shunt resistor just to a breadboard and then do the changes there where you have a lot more space to work, no risk of damaging the expensive card. And then if you don't know the resistance level at which you go into 2D clocks, you could just play with switching shunts until you find it. And you're not doing it on a live board. So I sent this idea all excited over to Buildzoid, and he answered me to answer your question. I asked about the wires and breadboard solution. He said, quote, wires have enough resistance to screw up the shunt mod. So unfortunately, it would not work. But great question nonetheless. As for the rest of the question, you can remove liquid metal if you do liquid metal to short the shunts. Liquid metal is not necessarily, we've never really recommended it, but in terms of shunt resistors, it's great for cooling a CPU die directly to the IHS though. That is the perfect use case for it. But for a shunt resistor, it works okay if you're trying to do some competitive overclocking, you're chasing points, stuff like that. I've never liked it for long-term 24/7 use in a gaming system, but for overclocking competitively, it's a great way to kind of get into it without going all the way to shunt resistor mods. And all the way is not really that big of a jump. It's just that if you don't have any experience with that stuff, you might want to start with something easier. So you can remove liquid metal. You can remove the second shunt resistor too, for that matter. I did it earlier when I was practicing on these. But either of those things, removing the shunt resistor if you did, let's say you did 5 milliohms instead of 8. And it is milli, by the way. Someone was trying to say it's mega. It's not. It's milliohms. But if you remove the 5 milliohm shunt resistor because you're stuck in 2D clocks, it will go back to 3D clocks. It will unlock itself. It resets itself. It's not something that writes to memory yet. NVIDIA might get there. It's just something that's, when the card's on, it checks and either 2D clocks or not. And so you can always revert and fix it. And I think that answers all those questions. Yes. Okay, next one. Why don't cases have side intake? Amonis asked this. Why did case manufacturers stop making mounts for a fan on the side of the case? Would a fan help in a meaningful way with side-mounted GPUs? Well, it'd help with any GPUs. We have tests on the HalfX and even the Zonda O, which is the worst computer case I have ever intentionally purchased or received at all, for that matter. We have a review of it on the channel. But the one thing it did really pretty damn well was GPU cooling. And that's because I had a side intake right at the GPU, which is horizontal, but it's still right at the GPU. So yeah, I mean, side intake's great for cooling video cards. Or I guess CPU, if you point out the CPU instead. But typically they're at the video card. They're extremely good for that. There's a few problems with them, but the biggest one is figuring out how to install it into a tempered glass sheet. As soon as that became the trend, everyone stopped because you pretty easily do a fan in acrylic or a fan in metal. But a fan in tempered glass for a while was just not possible in the computer hardware industry. And eventually, as the tooling started coming out, yes, manufacturers started figuring out, oh, we could cut a big hole in the glass, but no one's using it for that. The yields go down tremendously. The structural integrity of the glass goes down. There's shipping problems. So no one, oh, also the biggest thing, it doesn't look good. So, which is actually kind of valid in this case. But yeah, that's the main reason. Glass is the answer to your question. Would it help? Yes. They're not common anymore. Another reason they stopped is because it is kind of a pain. You've got a wire that's going into the board. It looks ugly. Cable management's gotten really big now, so people care about that. It can cause bent fan headers when you pull the side panel off because you forget the fan's plugged in, stretching the cable. What I'd like to see is on cases that maybe do a steel side panel or something, is if they do pins to pads, kind of like the front panels do, where it's just LEDs in the front, it's pin to pad instead of a cable. You could do that on the side panel and power a fan that way, and then you wouldn't need the cable. But that still doesn't fix the glass problem. So yeah, that's why. Jan Cortez says, do you, Steve, answer the AskGN questions by yourself, or do you sit down with the team to make sure you have the whole team's opinion on the questions? This reminds me of Linus's April Fool's video, where it's like, it's all a fraud and he just pays people to do everything for him. So no, I actually do these completely on my own. The few things with this, I consult a team for a few things. I think we've had Andrew on for AskGNs a couple times for 3D graphics questions. He's a 3D artist. He works in Unreal Engine. He works in Blender. He knows a lot about game graphics. If you ever have questions about them, leave them in the comment section below, and I'll get Andrew on to answer some of them. But he specializes mostly in Blender and 3D and in Unreal Engine, if you wanted to target the questions. But yeah, so I've had him for those, and for video scripting, like for the normal videos, Patrick writes a good amount of them. I write a good amount of them, and we split the work there. Patrick writes the build sections for the case reviews. He often writes the thermal sections. Sometimes I'll write them or at least add extra analysis to it. But we split the work in pretty much every other type of video except AskGN. Stupid CPUs. Except AskGN. AskGN was started because I had one editor at the time. It was Keegan. And was it? Yeah. Oh, yeah. It was Keegan and Andrew were kind of trading off. So it was Keegan to start, and then later on Andrew came in and took over while Keegan started school. But anyway, whenever we started AskGN, whichever of the two original editors I was working with for that specific day, when we decided to start, the goal was we need to create content that is easy for both of us. It needs to be something I can pull questions and answer them without thinking too hard about them. And if it requires a lot of thought, then we make a separate video on it. And you, the editor, can basically drop it into the timeline, cut out any cuts, and then that's it. So that was the whole point. We didn't want it to be complicated, and we've kept that format for this one. Let's do these last two. Vince says, I'll be in Taiwan next month. Anything worth visiting in Taipei from an IT perspective? I love Taipei. Taipei is my favorite place in the world to go to. So for a lot of reasons. I mean, I paused to think, like, well, do I prefer the downhill bike parks over Taipei? But the thing is that Taipei is like integrated with mountains and forests, so you have pretty much everything there. But as far as IT stuff, Guanhua Digital Plaza is a lot of fun, especially the first time you go. I'd highly recommend that. The cab might take you to Sign Trend. It's a big building with like an oval on it. It's 12 stories, and it's got like a Gundam store in it. Those are your landmarks. That's not where you want to be. I mean, maybe it is, but for different reasons. What you want to be in is the older, grungier building and the street level and the underground level. There's a set of stairs that goes underground under this old shopping center. There's like wires everywhere. It's all hacked together. It's an older part of the city. And Guanhua Digital Plaza has a ton of cool electronics. Strongly recommended. You may be able to set up a visit with some of the companies there. There are a lot of them if you are in the IT industry and you have some relevant reason to be there. Other stuff, I mean, there's Audio-Technica stores just randomly on the street. The one we visited had a white noise chamber where it just dumps noise into the room like an airplane, and then you put on the headphones and try it out. That's kind of cool. But yes, there's a ton of stuff. I would strongly recommend Guanhua Digital Plaza, I think, for the main tech visit. Sign Trend is a lot of fun as well. It's expensive, though. It's not like the other ones. So that's my IT answer. But yeah, Taiwan's great. Strongly recommended. Right now, probably not the best time. Taiwan's still safe in terms of human malware, but it's the matter of getting there, and then can you get out of the country? Can you even get in the country? Can you return home? But for the future, you know, it's a good place to visit. Is this the last one? Yes. Last one, a Herculean phone toss. Jacob Finley says, was that phone broken before he threw it? The phone in the Raycon ad is abused, and at this point it's a prop. Keegan dropped, that was his phone, he dropped it down a flight of stairs in Austin at the NVIDIA GTX, I think 980, oh no, 10, it was the 10 series launch. He dropped it down probably about 15 feet of stairs. I watched it bounce head over heels down the stairs, and it survived. And he used it for many more years, and now it's been retired, and it's our prop phone for the office. So no, we are not hurting a good phone. That's it for this one. Thanks for watching. Subscribe for more. Go to store.gamersnexus.net to help us out directly, or patreon.com/gamersnexus to get access to the bonus episode. And I'm going to record that one next, so check that out on the Patreon Discord if you have access to it. We'll see you all next time.